Module 3.1 Quadratic Equations and Rectangular Coordinates. This is sections 1.4, 1.5, and 2.1 in your book. Module 3.1 Opener. Quadratic equations are used to model projectile motion. That is, the motion that an object makes when it's thrown up into the air. Projectile motion. And other real-world situations. Quadratic equations are very important. We also use trigonometry to model motion. So a lot of the techniques that we're going to learn now, we can apply later on when we learn trig. Here are some important concepts to focus on. Quadratic equations can always be set equal to 0 and solved using the quadratic formula. So when we get to the quadratic formula, make sure you absolutely memorize it. You can always solve quadratic equations using the quadratic formula. When working with application problems, make sure you use the problem-solving steps from before. Right? So remember, what were those? Draw. Right, have scratch paper, of course. Scratch paper. Then sketch the problem. Draw out the problem. Write down what you know. Everything that you know, you have to write it down, even if it's already given to you. Then write down what you're trying to find. What are you trying to find? Right? And then start working on the problem. But make sure you plan it out first. Solving quadratic equations. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0. In other words, the most important thing here is that there should be something in front of the x squared. The highest term should be x squared. And that it should be set equal to 0. So as an example, or it could be able to be set equal to 0. As an example, 2x squared plus 3x is equal to 1. That's a quadratic equation because we can write that as 2x squared plus 3x. We could subtract 1 from both sides, which would give us -1 is equal to 0. So in this case, our a would be 2, our b would be 3, and our c, you have to be careful here, would be -1. Okay. Another type of equation, quadratic equation, would be something as simple as 4x squared is equal to 0. Right? We have a highest term of x squared, and it's set equal to 0. So we have a quadratic equation. The zero factor property is going to be very useful for solving quadratic equations, especially when factoring. And we've already looked at this before, but it says that if two things are multiplied together, and it has to be multiplication between them, if two things are multiplied together and they're set equal to 0, then one thing or the other thing have to be equal to 0, or maybe both, or both. So remember, we looked at an example like 5 times x is equal to 0. If we have 5 times x equal to 0, then we know that either 5 is equal to 0 or x has to equal 0. It doesn't make sense that 5 equals 0, so that's not possible. So that says that the only option is that x is equal to 0. Right. Same thing if we have something a little bit more complicated like 7x plus 3 times 3. Equal to 0. Either 3 is equal to 0 or 7x plus 3 is equal to 0. It's not possible that 3 is equal to 0, so all you have to worry about is the 7x plus 3 being equal to 0. And then all you have to do is solve for that. So let's look at a more complicated example. 6x squared plus 7x plus 2 is equal to 0. How can we solve for that? Well, we want to use the concepts we just learned. So maybe let's try to write this into a product, into a multiplication problem instead of an addition problem. Remember, we can do that by factoring. This is a quadratic equation where the leading coefficient is not 1, so we have to use the guess and check method. Let's check the factors of 6. The factors of 6 are 1 and 6 and 2 and 3. Right, those are all the ways we can multiply two numbers to get 6. So we're going to guess that maybe the problem looks like, let's try 2 and 3 instead of 1 and 6, 2 and 3. 2x and 3x. And remember, we also need the factors of 2. The only factors of 2 are 2 and 1. So because these two signs right here are pluses, we know that these two signs here have to be pluses. Right? We can't get a negative sign anywhere. And we just have to choose where to put the 1 and where to put the 2. Either 1 here or 1 there, or 2 there and 2 there, or 2 there. We have to figure out where to do that. Or if we put 1 here, eventually we'll do 2 times 2 there, and 1 times 3, so that would give us 7, so that's the right thing. Let's try that. 1 here and 2 there. And it should equal 0. But let's check it just to make sure. 2x times 3x is 6x squared. 2x times 2 is 4x. 1 times 3 is 3x. 1 times 2 is 2. Equal to 0. Sure enough, this is equal to 7x, so we did the right factorization. Now that we know that we factored it correctly, we're going to use that factor. We're going to use the zero factor property. Since two things are multiplied together to give you 0, 2x plus 1 times 3x plus 2 is equal to 0. And then we know that either 2x plus 1 equals 0 or 3x plus 2 is equal to 0. And we can just worry about them separately now. Solving for 2x plus 1 is equal to 0 is easy. All we have to do is subtract 1 from both sides and divide by 2. Subtract 1, divide by 2. So we get x is equal to negative 1 over 2. Same thing here, we're going to subtract 2 from both sides, which would give us 3x is equal to negative 2. And we're going to divide by 3, which would give us x is equal to negative 2/3. And there's our two solutions. Square root property. This is an important property also, and it says that if you have something squared, and it's equal to some other number, then the solutions to that something are x is equal to plus or minus the square root of b. In other words, the plus or minus the square root of whatever's on the other side. So as an example, x squared is equal to 8. The solutions to that are going to be plus or minus the square root of 8. And then all you have to do is simplify. X is equal to plus or minus the square root of, instead of 8, I'm going to write 4 times 2. X is equal to plus or minus, the square root of 4 is 2, so I'm left with just this other 2 in there. And those are your two solutions. X is equal to positive 2 square roots of 2, and x is equal to negative 2 square roots of 2. Same thing here. X plus 2 squared minus 9 is equal to 0. To use the square root property, we have to have something squared is equal to something else. So we need to do one step first. We need to add 9 to both sides. Then we have x plus 2 squared, something squared, here that cancels out, is equal to 9, is equal to something else. So now we can use the square root property to say that the solutions are x plus 2 is equal to plus or minus the square root of 9. The square root of 9 is 3. So our two solutions are x is equal to, we can subtract 2 here from both sides, negative 2 plus or minus 3. In other words, x is equal to negative 2 plus 3, which is 1, and x is equal to negative 2 minus 3, which is negative 5. Complete in the square. This is one method of solving equations of the form x squared plus bx is equal to 0. And we're going to really use it just to try to understand where the quadratic formula comes from. But completing the square is also very useful sometimes. Okay. Notice that the leading coefficient is 1 in this example here. We have x squared, just x squared. Okay, so we're going to make sure, later on we're going to need to make sure that our leading coefficient is always just 1. What we're going to do is we're going to move c to the other side of the equation, to the right side of the equation. We're going to take the c and subtract it. If it says plus 5, we're going to take minus 5. If it said plus 6, it'll be minus 6. If it says negative 10 or minus 10, we'll add 10 to both sides. Right? So just move it to the other side using the appropriate arithmetic. Okay. And then now that we only have the x squared plus bx on the left side, all we're going to do is take half of b. We're going to take half of b here, and we're just going to add it to the x, and we're going to square all that. So we'll have x plus half of b squared. And on the right side, we're going to have half of b again, but we're going to square that little quantity. And then we'll have something that we know how to solve. We can solve using the square root property. So the whole point of this is just to remember to add half of b on the left and square all of it. And then on the right side, add half of b squared. So this can be confusing, but let's look at an example. Okay, solve for 9x squared minus 12x plus 9. Same thing as before, but now we're going to use completing the square. Notice that there's not a 1 here, right? So remember we need to have a leading coefficient of 1, so we're going to divide everything by 9. Every single thing by 9 on both sides of the equation. So we have 9x squared over 9, which is just x squared. Negative 12 divided by 9 is negative 4/3, because 3 goes into both of them. 9 over 9 is 1. 0 over 9 is 0. Okay, and now we just need to trust the system, completing square, that it's going to work. X, we're going to take half of b. B is negative 4/3, so half of that is divided by 2 is negative 4/6. All we do is multiply those two numbers. So we're going to take minus 4/6 and put it there, squared, plus, remember we're supposed to move this 1 to that side, so actually you should say 0 is equal to 0 minus 1, which is negative 1, plus half of this number, half of negative 4/3 is negative 4/6 squared. So we have negative 4/6 squared. And then we need to we have on the left side x is equal to negative 4/6 squared. And on the right side we have some number that we need to figure out. So let's use the calculator to figure that out so we don't spend too much time on this. So we have negative 1 plus negative 4 over 6, not over 3, but over 6 squared. It's a fraction, it's a decimal, so we need to write it as a fraction. So we're going to go to math here, fraction, the first option, and then hit enter one more time, and we get negative 5/9. All right, 5/9. And we have our solution now. This is something that can be solved using the square root property. We have something squared is equal to something else. So the solutions are x minus 4/6 is equal to plus or minus the square root of negative 5/9. And then we're going to add 4/6 to both sides. X is equal to 4 over 6, positive 4 over 6, plus or minus the square root of negative 5 over 9. And let's leave it like that for now, since we haven't talked about the square root of negative numbers. Using the quadratic formula. This is the most important, one of the most important formulas you'll learn, because it can be used to solve any type of quadratic equation. The quadratic formula will always work. If factoring doesn't work, use the quadratic formula. If complete and a square doesn't work, use the quadratic formula. If anything doesn't work, use the quadratic formula. It always works. And you have to memorize it. Right? The quadratic formula says that things of the form ax squared plus bx plus c equal to 0 have solutions. X is equal to negative b plus or minus the square root of b squared minus 4ac. All of that over 2 times a. So let's look at an example. We're going to solve the same thing from before, 9x squared minus 12x plus 9 equal to 0, but this time we're going to use the quadratic equation. So notice that here our a is equal to 9, our b is equal to negative 12, be careful, negative 12, and our c is equal to 9. And we're going to write our solutions now. We don't have to do any more work, just write down the numbers. X is equal to negative b, or negative 12, which is positive 12, plus or minus the square root of b squared. Negative 12 squared is 144, minus 4 times a times c. In other words, 4 times 9, all over 2 times a. All over 2 times 9. So we have 12 plus or minus 144 minus 4 times 9 is negative 180. All over 18. Okay. And I'm not going to simplify this, but if you were to simplify this, you'll see that you get the same answer as before. But the quadratic formula is a lot easier once you have it memorized. And again, it always works. We call the expression under the radical sign in the quadratic formula the discriminant. Remember, this is the part said negative b plus or minus negative b plus or minus the square root of b squared minus 4ac. That little part right there is called the discriminant. And it tells us a lot of things. If all of that in the inside of the square root sign was equal to 0, then the quadratic equation only has one solution, one real solution. If all of that on the inside is just bigger than 0, if it's something like 150 or 12 or 1, anything, then you know you have two real solutions. If the quadratic formula is less than 0, so something like negative 1, negative 30, anything that's negative, then there are no real solutions. Right? We'll have something called complex solutions that we'll talk about later. 0 means one solution. Bigger than 0 means two solutions. Less than 0, no real solutions. So how many solutions does x squared plus 3x minus 2 have? If we were to use the quadratic equation, we could solve for this. We could say x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Right? We know our a here is 1, our b is 3, our c is negative 2. But we're not going to solve. We're just going to use b squared minus 4 times a times c to see how many solutions we have. B squared is 3 squared. 3 squared is 9. 4 times a is 1, so 4 times 1 times c is negative 2. So we have 9 minus 4 times 2 is negative 8, so plus 8. 9 plus 8 is 17. 17 is bigger than 0, so we have two real solutions. Okay. Now for the application problems, we're going to review some of the useful formulas, like Pythagorean theorem. Pythagorean theorem says that in a right triangle, in other words, a triangle where one of the angles is 90 degrees, remember this symbol stands for 90 degrees. In a triangle where one of the angles is 90 degrees, and we can label our sides A, B, and C, then this property will always hold a squared plus b squared has to equal c squared. And you can use that with some algebra to solve problems. Projectile height. So imagine yourself taking something, an object, and shooting it up into the air with some initial velocity, some initial speed. Right, it'll shoot up in the air and eventually it'll drop back down and hit the ground. Okay. That's called projectile motion. The height of the object at any given time can always be found using S is equal to negative 16 t squared plus v naught, or our initial velocity, sometimes called v sub 0. This v sub 0 is just our initial velocity, times the time plus s sub 0, which is our initial position. So v sub 0 is initial velocity, s sub 0 is initial height. So again, the position at any time, s, is given by negative 16 t squared plus our initial velocity times time plus our initial height. And this is if the equation is in feet, by the way. Right, the problem is in feet. It says the initial velocity was blank feet per second. But if we're talking about meters per second, then the equation looks like negative 9.8 t squared plus our initial velocity plus our initial position. So a little bit different here. It's actually negative 9.8 divided by 2. You can use 4.9. Let's do that instead to be a little clearer. Negative 4.9 in meters. So always make sure you're working with the right units. This equation if we're working in feet, and this equation if we're working in meters. Okay, so memorize those two definitely. And let's look at some problems here. And again, we're going to use the same problem solving steps for application problems as before. We have one leg of a right triangle has a length of 5 meters, and the other sides have lengths that are consecutive integers. Remember, integers are things like 1, 2, 3, 5, 7, right? Not any like fractions, not like 7/5 or anything like that. So consecutive integers means like you have to go from 2 to 3, or from 3 to 4, or from 7 to 8, but you can't skip anything. So let's draw this out. We have a right triangle where one side, it says it has a length of 5 meters, and the other two sides are consecutive. So we don't know what they are. Let's call this side x, and we know this side has to be x plus 1. One more of whatever this is. We can't switch this around. We can't say this is x and this side down here is x plus 1, because the hypotenuse has to be the longest side, right? Makes sense. All right, so now we're going to use the Pythagorean theorem actually. Pythagorean theorem says that 5 squared is equal to 5 squared plus x squared should equal the hypotenuse squared. X plus 1 squared. And then we're going to solve. This is 25 plus x squared. When we multiply this out, and you should do this yourself, remember this is equal to x plus 1 times x plus 1. But when we multiply and combine, we get x squared plus 2x plus 1. Notice that we could subtract x squared from both sides, which would give us 25 is equal to 2x plus 1. Then we could subtract 1 from both sides, which would give us 24 is equal to 2x. We can divide both sides by 2, which would give us 12 is equal to x. If x is equal to 12, then x plus 1 has to equal 13. And we're done. A projectile is launched into the air with an initial velocity of 128 feet per second. So already, since it says feet per second in a projectile, I should already write down my projectile equation, which says that the height at any given time is equal to the initial height plus the initial velocity times the time minus, and again it says feet, so we need to use 16 t squared. Okay. And it says assuming the projectile is launched from ground level, in other words that's our initial height, initial velocity is 128. When will the object reach a height of 512 feet? So this is saying that our initial height is 0. So this is 0 t squared, sorry, 0 times t plus our initial velocity is 128 times t times the time minus 16 t squared. So our formula for the height is s is equal to, this is 0, 128 t minus 16 t squared. It says when will the object reach a height of 512 feet? In other words, when will the object's height be 512? We set s is equal to 512 and we let everything else be the same, and we're going to solve for t. This can be solved using the quadratic formula. Subtract 512 from both sides. We get 0 is equal to 128 t minus 16 t squared minus 512. Be a little careful here. Our a now is what? Our a is 16, negative 16. Remember, our a is always what's in front of the t squared. Our b is what's in front of the t, so it's 128. And our c is just that extra number by itself. C is equal to negative 512. So we can use the quadratic formula. The solutions are t is equal to negative b, or negative 128, plus or minus the square root of b squared, 128 squared, minus 4 times a, 4 times negative 16, times c, all of that divided by 2 times a, 2 times negative 16. And then all we have to do is simplify that. I'm just going to leave it like that for now. Let's look at when the object will hit the ground. When will the object return to the ground? Well, instead of saying s is equal to 128t minus 16t squared, we say 0 is equal to 128t minus 16t squared. Because the object will hit the ground when the height is 0. And then we're going to solve. This we don't even use the quadratic formula for. We don't even need that. Here we can factor out a t. We're left with 128 minus 16t. So we have two solutions. Either t is equal to 0, which is true. At the very beginning, the object started at a height of 0. But that's not what it's asking. It's asking us when will the object return to the ground level, not when did it start at ground level. So we don't want this one. Okay. And we also have that 128 minus 16t is equal to 0. We can subtract 128 from both sides, and then we can divide by negative 16. And then that would give us t is equal to, again, subtract 128, divide by 16. That would give us t is equal to 8 seconds. So that's the time when it would hit the ground again. Objective 5, the rectangular coordinate system. Now we're going to start drawing out these graphs of quadratic equations and polynomials and things like that. An ordered pair consists of two numbers, x and y, two numbers, x and y, where the y component usually depends on the x component. For this reason, the y component is called the dependent variable, and the x component is called the independent variable. So some examples of an ordered pair, something like the set of the numbers 0, 1, right, that's an x and a y value, 0, or let's say 1, 3, and negative 5, 2. That's the set of three numbers, 3 points, x, y's, and xy's. And let's look at the coordinate system here down here. In the rectangular coordinate system, we arrange the x values and y values into two perpendicular lines. So let's write one line and then draw another line that are perpendicular. In other words, they intersect at a right angle. The one that's horizontal is called the x-axis. That's where you put our x values. And the one that's vertical is called the y-axis. That's where you put our y values. So for this example up here, x, y, 0, 1, that would be an x value of 0, so we don't move on this axis, and a y value of 1, so we go up 1. Let's say that's here. So 0, comma 1 would be this point right here, right on the y-axis. The point x, y being 1, 3, 1, comma 3 would be an x value of 1, so you move to the right 1, and a y value of 3, 1, 2, 3. So this point up here, 1, 1, 2, 3. Negative 5, 2 would be an x value of negative 5, 1, 2, 3, 4, 5, but at the same time a y value of 2, 1, 2. So negative 5, 2 would be right there. The distance formula. So using the Pythagorean theorem, we can find the distance between any 2 points on that coordinate axis. So let's imagine we have a point. x1, y1, and we have another point x2, y2. Let's say it was down here somewhere. Then we want to use the Pythagorean theorem to find the distance between those 2 points, that distance right there. Notice you can always form a triangle, and that's how we get the distance formula. The distance, this length right here, is always found by taking the square root of the difference in the x values squared and the difference in the y values squared. Because that's what this is right here. This is the difference in x values. This is the difference in the y values. This is y2 minus y1. This is x2 minus x1. And the Pythagorean says that you can square both of those, add them together, then take the square root to find the other side. So to find the distance between this x1 comma y1 and this x2 comma y2, we just used the distance formula. The distance between those points is the square root of x2 minus x1, so 2 minus a negative 4 squared plus y2 minus y1, 0 minus 2 squared, which is 2 minus a negative 4, 2 plus 4 is 6, 6 squared is 36, 0 minus 2 is negative 2, negative 2 squared is positive 4. So this is just the square root of 40. The square root of 40 is the square root of 4 times 10. The square root of 4 is 2. The square root of 10 is just the square root of 10. So 2 square roots of 10 units away. The midpoint formula between two coordinates, in other words, if we wanted to find instead a point in between those two values, just somewhere in between, all we take is the average of the x values and the average of the y values. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Just average out those values. So here, for our x1, x2, x1, y1, x2, y2, we average out those values to find a midpoint. x1 plus x2, 2 plus 4 is 6 over 2. y1 plus y2, 8 plus 9 is 17 over 2. 6 over 2 is 3, 17 over 2 is just 17 over 2. And we're done. Graphing equations in two variables. Ordered pairs are used to graph equations in two variables. Okay. So as an example, this is an equation with two variables, an x and a y there. And you can find lots of solutions that will make that equation true. All you have to do is try different values for x. So for example, if x were 1, then this equation would read 1 plus 2y is equal to 3. So that would tell you, if you subtract 1 from both sides and divide by 2, that y has to equal 1. Likewise, if x is equal to 2, this equation would read 2 plus 2y is equal to 3. If you subtract 2 from both sides, you get 2y is equal to 3 minus 2. 3 minus 2 is 1. Then divide by 2, we get y is equal to 1/2. So we have 2 points already. For this set of solutions, we have 1, 1 for our x and our y. And for this equation down there, we have 2, 1/2. Again, our x was 2, and then we found our y was 1/2. An intercept is a point where the graph of an equation intercepts the x-axis. That's what an x-intercept is, where it intercepts the x-axis. And this always happens when y is equal to 0. So in our equation up there, to find an x-intercept, to find where the equation intercepts the x-axis, right here, when is that true? All we have to do is set y equals 0. So we would say x plus 2 times 0 is equal to 3. But 2 times 0 is 0, so that tells us that x is equal to 3. In our equation, when x is equal to 1, 2, 3, y will be equal to 0. And we have found our x-intercept, 3, 0. A y-intercept is when the equation intercepts the y-axis, but it happens when x is equal to 0. Y-intercept is when x is equal to 0. X-intercept is when y is equal to 0. So we're going to do that. Instead of x plus 2y is equal to 3, we have 0 plus 2y is equal to 3. But that just says that 2y is equal to 3, and that just says y is equal to 3/2. So when x is equal to 0, in other words, when we haven't moved here yet, we have 1, 2, 3. Y is equal to 3 over 2, or a little bit above 1, about 1.5. That's our y-intercept, and this is what our line would look like. It crosses those 2 points. It crosses all of these points actually. 1, 1, 2, 1/2. 1, 1 would be right there. 2, 1/2 would be right there. Notice that all x-intercepts look like some x value, comma, 0. All y-intercepts look like 0, comma, some y value. So try these examples on your own for a second. Alright, so given that we have 4x minus 2y is equal to 2, how can you find the x and y-intercepts? This should come easily after some practice. So x-intercept is when y is equal to 0. So now I'm just going to write down the equation. 4x minus 2 times 0 is equal to 2. 4x is equal to 2. X is equal to 1/2 after I divide both sides by 4. So my x-intercept is 1/2, 0. Same thing for the y-intercept. X is equal to 0. So I'm going to write down 4 times 0 minus 2y is equal to 2. In other words, negative 2y is equal to 2. In other words, y, after I divide both sides by negative 2, y is equal to negative 1. And my point is 0, negative 1. Graph x squared minus 4 by finding the x and y intercepts first. Okay, again, x-intercept is when y is equal to 0. So instead of saying y is equal to x squared minus 4, I'm going to say 0 is equal to x squared minus 4. I'm going to add 4 to both sides. I'm going to use the square root property to say the solutions are plus or minus the square root of 4. The square root of 4 is 2. So I have 2 x-intercepts. Plus 2, 0, and negative 2, 0. And the y-intercepts is when x is equal to 0. So instead of writing y is equal to x squared minus 4, I'm going to write y is equal to 0 squared minus 4. Or y is equal to negative 4. So my y-intercept is 0, negative 4. And I'm going to put my x and y axis 2, 0, 1, 2, 0, negative 2, 0, 1, 2, 0, 0, negative 4, so 0, 1, 2, 3, 4. Looks like this. Okay, if you were to sketch more points, you'll see that the graph of this equation looks like that. We call that a parabola. One more. Use any method of your choice to solve for 3x squared plus 2x minus 1. Okay. And again, remember, the quadratic formula always works. So maybe you want to use the quadratic formula because it always works. You could use complete in the square. You can use factoring if you can factor it. You can use some technology if you want to use technology. Let's use quadratic formula, and then we'll use some technology to see what the answer is. Quadratic formula says that the solutions to this are x is equal to negative b. Remember, this is our b, that's our c, that's our a. Negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a times c, all divided by 2 times a. So negative 2 plus or minus 4 times 3 here is 12. Negative 12 times negative 1 is positive 12. 4 plus 12 is 16. 2 times 3 is 6. Square root of 16 is 4. And all of these numbers can be divided by 2. So we have negative 1 plus or minus 2 over 3. Those are our two solutions. X is equal to negative 1 plus 2. Negative 1 plus 2 is 1 over 3. And x is equal to negative 1 minus 2. Negative 1 minus 2 is negative 3 over 3, or negative 1. Okay, and now let's use some technology to solve this also. And go to the y equals option up here to the in the top left, and we're going to type in our equation 3x squared plus 2x, oops, to go back, plus 2x minus 1, and we're going to hit graph. And if it doesn't graph correctly, you might have to go to the zoom option and try out different zoom options. Zoom standard is what it's usually set at, so let's try that. 6 here. Yeah, there you go. There's our parabola, and this is something left over from something else. There's our parabola. Right. And we were trying to figure out when it would cross the x-axis. So we were trying to figure out those two values right there. There's an option here under calculation. If you see right here, it says calculate right above trace. So we're going to say second trace, and we're going to go to the 0. That's what that's another name for the x-intercepts. So we're going to hit enter. And it says, what is the left bound? In other words, go to where you think it's crossing the x-axis right there, and then go to the left of it a little bit. Hit enter. Now it says, what is the right bound? So go down a little bit. Right there. Hit enter. And then it says, take a guess. So it says, help me out, basically. Help me figure this out. So I'm pretty close there. I just need to get close to that x-intercept and not that close to this x-intercept. I'm going to hit enter. And it says the 0 is when x is equal to -1. See, that's when y is equal to 0. Which coincided with what we found. We found that x is equal to -1 was an answer. Now let's do the same thing for this other one right there. Second, calculate. 0. It says, what is the left bound? Just go to the left of it a little bit. There you go. We're a little bit to the left of it. Enter. Right bound. Go to the right of it a little bit. So I'm going to keep going right until I pass it. I'm going to hit enter. Now it says take a guess. So now I'm going to go to the left again until I'm pretty close to where it's going to intercept. I'm going to hit enter. And it found that x is equal to -0.33333, which is equal to 1/3. If you're not sure, and if it can be turned into a fraction, what you can do here is you can quit, second, quit. Then you can go straight to math, hit fraction, hit enter, and it'll turn that decimal into a fraction, 1/3. But you have to go straight to it. Okay. So again, we found -1 and 1/3 were solutions using the quadratic formula and using the graphing calculator. You should now be ready to start 3.1 homework.